Hello everyone, in this video I'm going to be going over valence bond theory. So basically what valence bond theory states is that bonds form when half-filled orbitals overlap. So we're going to be going back to our orbital notation that we learned in the last unit, and that's going to help us with our valence bond theory. So I have an example down here where we have hydrogen and hydrogen. So what those orbitals look like, it's going to look like a 1s and a 1s with only one sad, lonely electron. So those are going to be the orbitals that overlap because those are the half-filled orbitals, right? So those are the only two half-filled orbitals that can be possible between hydrogen and hydrogen. That's because that's the only orbital notation that hydrogen has. So when they overlap, it's gonna just add together. It doesn't necessarily, it doesn't have to be in the 1s orbital, or this doesn't have to be in the 2p orbital, but what you do have to know is that they are overlapping and forming a bond because of that overlap, right? And then let's take a look at something like hydrogen and fluorine. So hydrogen, again, has that same orbital notation where the lone pair electron is in the 1s, not lone pair electron, the half-filled orbital is 1s, and then here we have a half-filled orbital in 2p for fluorine after we did the orbital notation, which would be right here. So those are the two that are going to overlap. So when they overlap, those two are just going to come together, right? So what that means is that the orbitals that overlap are going to be the 1s and the 2p. So that's really all you have to know for valence bond theory. It's a pretty short video here. So let's go over some practice problems. So I'll go over the first one, and I highly encourage you all to try the last few on your own. So let's take a look at sodium's orbital notation. 1s, 2s. Again, I'm just getting all of this from the periodic table. And this is going to be... Oh, actually, I don't even... Oh, yes, we do actually have this. Then we're going to have 3p. 2p. It's going to be 3s. So sodium is 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So our lone orbital is 3s, and then, or a single electron orbital, and then let's look at fluorine. Fluorine's going to be... Fluorine is number, I want to say 9. Alexa, how many protons does fluorine have?
Fluorine has 17 protons.
Alexa, how many protons does fluorine have?
Fluorine has 9 protons.
Okay, 9. I always use my Siri to help me out with that stuff because I'm too lazy to look it up. So we have a 1s, 2s, and 2p, so we're going to get to 9. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's our half-filled orbital, so it's going to be in 2p. So the orbitals that overlap in this scenario are going to be 3s. I'm just going to write it out a little neater here, 3s and 2p. So are going to be our orbitals that overlap. All right, let's take a look at BR2. For this, all I'm going to do is I'm going to actually write out just the last shell, which is going to be 4s and 4p. The reason why I'm doing that is because I know that the only ones that can bond are those outer shell electrons, and if we go back to the orbital notation video, we know that the outer shell electrons are only going to be the s and the p group, right? So we're just going to focus on that last energy levels, s and p group, because that's the only thing that can bond. So with bromine, I think it is, it's going to be 1, 2, 3, 4, 5, 6, 7. So it's going to look like that, and there's 2 of them, right? So let's do the same thing. Put like an and symbol between the 2 so we know that that's what's separating them. 1, 2, 3, 4, 5, 6, 7. It's going to be our 4p. It's going to be our 4s. Again, those lone pair, or not lone pair, I keep saying that. It's because what I always think of. Those orbitals that are half-filled, so our half-filled orbitals are both going to be in the 4p. So our answer here is going to be 4p and 4p. It's a lot easier if you use that shortcut, so I do highly recommend that if you're going to be doing a problem like this. Alright, so let's take a look at chlorine. Chlorine is in the third energy level, so let's take a look at the third energy level of chlorine. It's going to look like this, where we have 3s and 3p. Same thing for the other chlorine, it's going to be 3s and 3p. Chlorine, as we heard from my Alexa, has 17, but we know that chlorine has 7 valence shell electrons, same as bromines. It's going to be 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Same thing. Half-filled orbital is going to be in the little last part here, and it's going to be in 3p. So it's going to be 3p and 3p, not pill. All right, hydrogen. Boom, easy. That's hydrogen. And now let's take a look at chlorine. Sorry for the talking in the background. Chlorine is going to look like this. Chlorine again is going to be on that third energy level. So we have the 3s. 1, 2, 3, 4, 5, 6, 7. So it's going to be 1s and 3p, if I could write it correctly, 3p. So those would be our answers for that. I hope that this video helped with that explanation, and thank you all for watching.